Hi, and welcome to Geeks for Geeks. Today, we would be discussing the problem index of the subarray sum. So, as the name suggests, we need to find a contiguous segment of the array which is sums up to the given target, like 2, 3, 7 sums up to the target 12. Then what is the scenario? Then what is if the target is 15, 2 plus 3, 5, 5 plus 4, 9, 9 plus 5, 14, and then this is 15. So this is first to the fifth position. We have that. We don't have any contiguous part of the array which sums up to the given target. Fair enough? So now, what can be the scenario? The very first thing I can see is contiguous part of the subarray. So the very simple thing we can do is consider all possible subarray. What are the all possible subarrays? Like we can simply do for like if we have 5, 3 and 4. So the very first one we can have is just one element, then 5, 3, 4, then 5 and 3, then we can have 3 and 4, then we can have 5, 3 and 4. So we can consider all possible subarrays of size 1, then all possible subarrays of size 2, and then subarray of size 3. We have that. We don't have any issues doing this. So considering all possible subarrays is very easy for us. Okay, fair enough. This is what we can do. But considering all possible subarrays is big O of n square. And then we can just keep out the sum. We don't really need to find out the subarray every time. We can just keep out the sum. That would make it constant because one variable would be there to just see if it is equal to the target sum or not. So we don't really need to find out the, like as we progress, we can just keep the sum itself because the sum is the only thing that makes a difference here. Fair enough? This is what we can do. We can consider all possible subarrays of the position to the sum itself. Easy. So now, what can be the other approach? 1, 2, 3, 7, 5. Let's take the next one. So let's say the given array is 5, 3, 4. Why I consider an array like this? Because in the question, it is nowhere to be mentioned that we are given a sorted array. But these two examples are a sorted array. So it might be misleading, like it might mislead you to think of something which might align with sorted result. First, let us see if without just changing the array, given array itself, can we solve something like this or not? Let's see this. So we have 5, 3, 4. So let's say we are told that find a subarray and the target is, let's say, 7. Let's take a very simple example. So this is not sorted. So we can't really search the elements again and again. But if we sort it, then subarray thing won't be present. Why? Because subarray needs to be contiguous. So if the subarray is needed, which is to be contiguous, then sorting won't help. So we don't need to go through sorting. So can we do something like this? Like what we can do is, we can consider a window of size 1. This is equal to 5. As of now, 5 is less than 7. We know that. Then we include one more element in it because we know that we need to increase our sum. So now we have what? 8, which is greater than 7. So now what can we do? 5 plus 3 was 8, which is greater than 7. So what we can think of? See, if we move further, then the sum would increase more and that won't help us. So what can be the way we can think of? Can we do? Like we can just drop off this element. Now the sum would be again less than 7. And then we can try to include a new number. And then you would see that whatever the favorable condition is, if that is present, you would land it on it. So now let's take a very simple example to understand it better. So earlier the test case was really small. Let us take a better example than this. So let's say the right pointer is pointing to 7 and the left pointer is this. And as of now, if we just sum it up, the value would be 18, which is greater. So if I just increment this, like if I include more values in this window, then the sum would definitely increase. So that is why the intuition is to just drop off some element and see if the new element can be of use or not. And now and then we would definitely find the ideal condition if it is present. That was the intuition. Basically what we can do is we would simply have a left and a right pointer, and if the sum of left and right is less than the target element, we would keep adding more elements to the sum. If the sum is greater than that, we would just increment the left, like we would move the left pointer and decrement that from the sum. Okay, like it would be like this scenario. What we would do is I would just explain you more. So what we would do is we would have a left and a right pointer which would be both pointing to 3. So as of now the sum we have is 3. Then we know that 3 is less than 17, so we move forward, include 1 to it, it makes it 4. 4 is still less, we would move forward, make it 8, and then we again move forward, make it 11, and then we again move forward, make it 18 itself. Now when it gets greater than 17, what we would do is initially we would have left is equals to 0 and r is equals to 0. If the sum is less than the target element, the right would keep incrementing and the sum plus equals to a of right. We would keep doing that. If the sum becomes more than the target element, we would drop off some elements and we would move forward. And here we would decrement the sum of a of L. Okay, that is why we would just drop off this, subtract from 18, we would subtract 3, that is 15, and then add the new number 17. We have got it, and then we would just report L and R, adding 1 to it because the answer is 1 indexed. That is why we need to report that. Now let us move to the implementation. So initially we have S and E equal to 0 and the rest is equal to a blank one. Now we start off by iterating all the elements in the range. So we add that element into the current sum. If the sum becomes more or equal to the target, then we first have the start. Okay, and then while it is more, we keep removing elements from the front. After removal, if it becomes equal to the target, we just append it, else we return minus 1. Now let us see if this implementation would work or not. Okay, let us compile and run. This is working fine for the sample test case. Let's see if we can get an AC or not. And yes, we got an AC. Talking about the time complexity of the solution. So here again, the pointers are from left and right. Okay, like the pointers are from left and right, and they both are just moving forward. No one is coming back at this point. Okay, like we have both are moving forward. If this is moving forward, if the sums becomes greater, this is also moving forward. So it's like everyone is moving forward in their own pace only. So even if they are walking in the same pace and visiting each element exactly once, then counting the number of operation would be 2n. So that would be big O of n, and the space complexity would be constant again because we are only using variables and that don't contribute to the time complexity. Space and that don't contribute to the space complexity. So that was it from my side. Goodbye everyone. Thank you and have a nice day.